Okay, we have Mike coming. Mike is about to see if he can power up this transmitter with a 789. Is it on?
Yeah, it's reading milliamps.
How do you know that it's on?
It's reading milliamps.
Okay, very good. So what I want you to do is, I don't want you to turn on the hard communicator right now. I want you to measure the voltage across the resistance.
Okay.
I want you to measure the voltage across the resistance. Let me get right here.
You go parallel or you want
No, help him, Raul. Get in there and help him. I want to measure the voltage across that resistance. We did that earlier.
You have your resistor up there?
put it up there? On the same side?
That's okay. Where you gonna put the other one? No, put it on the other side of that blue resistor.
Oh, on this side.
Mm-hmm. It would have worked if you would have put it on that other one, but let's put it right there. Now, set your meter up to measure voltage. No. Check your leads, please.
Oh. Thank you.
That's okay. Always check your leads.
Yeah, I went to the right side.
So, do we have alternating current or do we have DC current?
Please.
Are we using alternating current or DC current?
See here.
So if you have DC current, you're going to have DC voltage.
Okay.
Is that DC, Mike?
AC. You want another one? Yes, please.
All right. So how many? So now what we want to do? Now we want to go with the communicator, and we want to drive that signal from 4 to 20. Can I'm gonna change this just a little bit where we can see it. It's okay. You're good. So now what I want to do, let's get in there and connect to the communicator. Let's put that communicator on there, Mike. Not on test. The communicator goes on the power. The milliamp is read on test, Mike. The communicator goes on the power. Okay, very good. Now what you gonna do? Voltage detected. You see a heart beating anywhere?
Yes, sir.
That means you're talking. It's just gonna take a little time. It's on its way. Once it gets everything pulled up, then I want you to go into simulate.
Search tools. Simulate. Do test.
Okay. So give me 4 milliamps and let's see what happens with the voltage across the resistance.
That mean anything? Did you see that?
Yeah, don't worry about it.
Can you simulate too? Other?
Did you put 4 milliamps on it?
We already on 4.
You can enter 4 right there. So how many volts across that resistance?
1 volt. DC.
How many?
One volt DC.
And that follows directly from Ohm's law, right?
Yes, sir.
So let's go to 12. How many volts are we gonna have at 12 milliamps?
At 12, we're gonna have 3.
We're gonna have 3 at 12. Let's see.
2.5.
Well, let's just see if you're truthful.
Oh, 3.
That's okay. 3.
Nice.
Let's go full scale at 20.
Can I press that or no? Or should I just put
You can push other, or you can push 20 milliamps. The least amount of steps is just push 20 milliamps.
I just want to know those.
Yeah, I mean, you're gonna get a chance to play on this thing.
So
And see, 5 volts at 20 milliamp signal with a 250 ohm resistor, you're gonna get 5 volts. So if you ever inside a system and you can check that with a voltmeter. If you don't have, you can just check it with a voltmeter to the signal ground, and then you'll see 5 volts. And then you say, oh man, this thing's full scale. 12 volts is at 50%, and you'll know. Okay? So go ahead and take this apart, and let's let Raul do it.